Hi, and welcome to Talking Wildfires. Today we're here with Phil Cheney again, and we're lucky in that he's going to share with us a paper that he did on the Canberra Fires in 2003. The paper actually came out in 2004. The Canberra Fires in Australia are important because they were a major event that led to a lot of other things within the Australian fire history picture. Phil, can you tell us about the Canberra Fires and about your paper?
G'day, Mike and people. My paper is called Canberra, Bush Capital or Bushfire Capital. The Bush Capital was a nickname that Canberra got because of its history, and my paper was presented to the ACT Historical Society, and it describes how conditions change from the original plan of Canberra into the current situation. I'll start. On the 18th of January 2003, bushfires burnt into the outskirts of Canberra with devastating consequences. The loss of 4 lives and 500 homes shocked our community to the core. However, a disaster in Canberra was inevitable. Even if the fire had been controlled in the mountains, it would only have served to postpone the disaster to some time in the future, almost certainly in the next decade. We, in the bush capital, had set ourselves to burn. We are not alone. The same factors that predisposed Canberra to disaster occur in every other part of Australia and other parts of the world, almost everywhere in places with a similar climate, where urban development is expanding, and in affluent communities where attitudes to fire, fire prevention and fire mitigation are changing. I spent my entire adult life studying bushfires, and it's a field in which the lessons of science and of history are hard won but easily forgotten. Fire in the bush is not a man-made phenomenon. Fire is an ecological process that has shaped the flora and fauna of the world, and it is as natural as the sun and the rain. It occurs wherever and whenever the climate produces a flammable environment. In Australia, bushfires have been around for at least 80 million years. For as soon as eucalypts appeared in the fossil record, charcoal was in there with them. The vulnerability to a bushfire disaster, however, depends not only on the physical factors of the environment, but also on the preparedness of the population. People can modify the environment, and their familiarity with fire determines the extent to which they are capable of self-help. The most devastating fire disasters occur where the phenomena is infrequent and the population is unprepared. Canberra was considered to be the safest and have the best protected interface with the bush of any city in Australia. So I'm going to examine both the physical nature of fire and the changes that have occurred in Canberra environment that led us up to January 2003. Fire is a chaotic chemical reaction that gives off heat and light. It requires dry fuel and some form of ignition. The fuel for a bushfire is primarily the dead grass, woody debris and twigs which build up in our forest and rural areas. Most of the year the fuel is too moist to burn, but under extreme fire weather, the very dry air sucks the last residual moisture from the dead material, and then the tiniest spark is capable of starting a fire. Under these conditions, the heat of the fire dries out green vegetation, so it too becomes fuel. Australia is a flammable continent. The rolling cycles of wet and dry seasons and periodic droughts provide that, sooner or later, fire will spread through abundant dry fuel across almost every hectare of the continent. Only the tropical forests of North Queensland are spared from widespread burning. In southern Australia, the rainfall pattern is such that there is abundant dry fuel ready to burn on 8 out of every 10 summers. All that is needed for a serious bushfire is a weather pattern where strong winds bring hot, dry air from the centre of the continent. When fires do burn during extreme weather, the speed of their development is staggering. On the McArthur fire danger scale, an index of 100 represents a day when the temperature is 38 degrees Celsius, the fuels are dried by a relative humidity of 8%, and the average wind is 50, gusting to 90 kilometres per hour. Under these conditions, grass fires can travel at an average speed of 20 kilometres per hour. Forest fires are slower, burning at around 10 to 12 kilometres an hour, but they can throw spot fires 10 to 15 kilometres ahead. From a single ignition on a day of extreme fire danger, both forest and grass fires can burn out more than 100,000 hectares in 8 hours. That's an area that is 50 kilometres long and 20 kilometres wide. The fire weather in Canberra in 8 January 2003 was extreme, an index of 80 on the McArthur scale. However, extreme weather is not all that uncommon. On average, Canberra experienced 3 to 4 extreme days every summer. Nor was this the highest recorded in Australia. On 7 February 1983, which we called Ash Wednesday, the fire danger peaked at 140 in parts of South Australia and Victoria. However, a bushfire still does need a source of ignition. If this doesn't occur, then the day of extreme fire weather passes mostly unremarked, with people merely observing to one another that it was just another unpleasant, hot and windy day. There are many unpredictable elements in forecasting the weather and the behaviour of a bushfire, but other factors are predictable. We can predict with certainty that the situation will again be chaotic. Communications will break down, power and water supplies will fail, there will not be enough firefighters, and they will be able to attend only a small fraction of the houses and the families under threat. It is also entirely predictable that the extent of the damage will depend on the number of people who recognised the fuel around their homes and had taken steps to reduce it, and also who are physically and mentally prepared to defend their own homes when the fire arrives. There are no guarantees. The best prepared and defended house may still burn down from an undetected spark that lodge in the building. In other cases, property owners may be prevented from defending their property by forced evacuation. Many Australians demand the right to assess the risk for themselves and stay and defend their homes, and in my opinion, this right should be enshrined in law for all Australians. The physics of combustion are well known. The intensity of a fire, or the rate it emits heat, depends on the amount of fuel consumed every second, which in turn depends on the speed of the fire and the amount of fuel available for combustion. At the top end of the scale, heat is released at a rate of 100,000 kilowatts along every metre of the fire edge. For comparison now, a large household bar radiator emits 1 kilowatt. So that's 100,000 large bar radiators stacked up along every metre of the fire front perimeter. Now, on the other hand, our ability to quell the sort of heat generated by an intense bushfire is puny. Under favourable conditions, tough and skillful firefighters on the ground can put out a fire of 2,000 kilowatts per metre. But this is only 2% of the maximum rate. It means that under extreme conditions, it is simply impossible to put out a bushfire by any means unless it is tackled within a minute or two of ignition or until it runs out of fuel. Now, there is a great irony that in developing Canberra into the bush capital, we were sowing the seeds of bushfire disaster. Developing bush also meant developing bushfire fuel. Most Canberra did not understand this. The bush was something out in the country. But Canberra was not always the bush capital. The vision of the city's great planner, Sir Walter Burley Griffin, in 1913 was, and I quote, "to relieve the surface tension of city life by placing within reach and enjoyment of every city dweller some attendant delights of the country." And as the Governor-General, Lord Dedman, amplified in the same year, he said, "Let us hope that here a city may arise where those responsible for government of this country in the future may seek to find inspiration in its noble buildings, its broad avenues, its shaded parks and sheltered gardens. A city, perhaps, bearing some resemblance to the city beautiful of our dreams." So onto the treeless plains of the Molonglo River, the Garden City was established. Broad avenues, shaded parks were planted, mostly with exotic species, and in particular, the deciduous hardwood trees of the Northern Hemisphere. Home gardens were prescribed, front fences were banned, and government workers trimmed hedges to a prescribed height and size. In 1952, the trimming by government was deemed too expensive, and many of the public responded either by pulling out the hedges or allowing them to grow unchecked. And by the mid-1960s, the growing fascination for Australian plants reached Canberra. Streetscapes changed their character. Street trees, which had been predominantly deciduous hardwoods with an occasional spattering of eucalypts, were now planted to native species. In Western Creek, eucalypts dominated the street planting. On the median strips of the broader avenues, the stately cedars and oaks and elms on irrigated lawns of the early suburbs were now filled with mixed plantings of native species, including eucalypts, acacias, melaleucas, and casuarinas, with extensive mulching to reduce the area of grass that needed to be mown. Many residents followed suit. The classical older Canberra gardens with fine specimen trees and weeded flower beds and green lawns gave way to new suburbs and native trees and shrubs, and mulches of natural litter and wood chips. Like-minded residents would run their gardens together, producing continuous areas of bushland, often right up to the house with a minimal area of mown grass. By 1980, bushfire fuel had arrived in the bush capital. Now, when you think about fuel, there is a critical difference between the deciduous hardwoods and the eucalypts. Deciduous hardwoods drop their leaves in autumn after the fire season and retain bark of low flammability on the stems. The leaves also retain nutrients in them when they fall, which makes them attractive to the soil, flora and fauna, so they decompose readily. By the next summer, there is little flammable material left to burn. On the other hand, eucalypts drop their leaves and shed bark in summer. They withdraw nutrients from the leaves before they shed them, and thus making them unpalatable to insects and fungi, so they decompose slowly on the ground. After 5 years, there is enough fuel to support a crown fire in extreme weather. In the words of our poet laureate, Les Murray, talking about eucalypts in California, and I love this, he says, "Standing around in shed branches and slabbings of bark is homeland stuff. But fire is ingrained. They explode the mansions of Malibu because to be a eucalypt, you have to shower sometime in hell." There were other changes. The suburbs established in the 60s gentrified. Short-lived native plants died, rental properties became more common, and dead fuels accumulated in neglected gardens. Species such as cypress and other exotic conifers, which retain extensive dead material within an outer mask of green, were older, larger, and even more flammable. 30 years of lifestyle detritus, including old tyres, lumber, plastics, and flammable chemicals, had accumulated in almost every suburban backyard. And there were changes in the country. Going back to 1859, rabbits were first introduced into Victoria. 50 years later, in 1910, they had spread in plague proportions to most of the country below the Tropic of Capricorn. That's roughly 2/3 of the continent. In drought conditions, the grasslands were denuded by rabbits, with not enough fuel to support a continuous fire. Farmers in the ACT commonly use fire. Paddocks of stubble were burnt each year before new crops were sown. Graziers regularly burnt the dry forest of the foothills of the Cotter Valley to regenerate and maintain native grasses. All of these factors influence the extent and intensity of fires in rural areas. In January 1939, there were 3 days of extreme weather in 4 days. That's the most hazardous period of extreme weather that has ever been recorded in this country. Huge bushfires burnt through the mountain forests of Victoria and southern New South Wales, including the Brindabella Ranges west of Canberra. However, the spread of fire burning directly towards the Canberra city was restricted by extensive areas of recently burnt forest in the Cotter Valley and by grasslands which had been practically denuded of all grass by sheep and rabbits. Although burning firebrands thrown up to 15 kilometres downwind from the Brindabella Range, they could only ignite new fires in the few isolated areas of bush south of the Sydney. The 1939 fire was Australia's worst bushfire event. Canberra was threatened but survived. But now there was another, more insidious and ultimately more damaging change afoot. Fire was disappearing from the consciousness of Australians. In earlier times, Canberra residents used wood fires for domestic heating and regularly burnt wastes in the garden incinerator. The majority of the population smoked tobacco, carried matches with them. Major roads had rest areas equipped with fireplaces, and travellers lit open fires to boil billies for tea. Rural residents burnt fire breaks around their home each summer. In 1952, there were 2 large fires near Canberra. One of them, started by lightning, burnt pine forests on Mount Stromlo and destroyed the National Observatory. But neither fire encroached directly on the suburban Canberra. They were events which entered into the consciousness and influenced attitudes towards fire at that time. And there were 2 other significant events in 1952. Mervyn Victor Richardson developed the first Australian rotary mower in his suburban garage, and CSIRO began the widespread introduction of myxomatosis to control the rabbit plague. In the first place, the Victor mower provided a means for Australian homeowners to turn grass into lawn, and to a large extent this removed the need for the tiresome task of burning off grass around the home when it first cured in early summer. On the other hand, the dramatic reduction of the rabbit population removed enormous grazing pressure from both grassland and forest vegetation, particularly during drought. This accelerated the build-up of fuel. From that time on, even in severe drought, the grassland in and around Canberra was never as bare as it was in 1939. Now, in 1960, Alan McArthur is the Canberra scientist now recognised as the godfather of bushfire science in Australia, published his seminal paper, Controlled Burning in Eucalypt Forests. This was the first guide which defined the precise weather and fuel conditions to produce a low-intensity fire that would reduce fuel loads and not give scorch or damage to any of the standing trees. It was developed with empirical research, that is, direct measurement of the spread and behaviour of experimental fires lit in the dry forests around Canberra. Even into the early 1970s, Canberra residents were unconcerned about burning off in the forests and the woodlands of the ACT. Every summer between 1962 and 1970, I assisted Alan with experimental burning on the foothills of Black Mountain and Bruce Ridge, pretty much in the centre of the built-up area. We collected data on fire behaviour in different fuel types and trained forestry students in manual fire suppression. We burnt experimental fires in crop stubble on the plains of the Woden Valley, and even burnt fires in paddocks surrounded by suburbs. Now, we did advise rural SEs and police of our activities, but the media ignored our burning, and there was never, to my knowledge, any complaint or unfavourable comment from the public about the fires or the smoke. Following McArthur's guide, aerial ignition of prescribed burns was introduced in Western Australia in 1966. In 1967, I carried out the first operational aerial ignition of forest in the mountains of the Brindabella Range, an area of around 4,000 hectares burnt in 2 days. Over the next 10 years, extensive prescribed burning every autumn laid smoke over the mountain country that was clearly visible from the city. I believe broad-scale prescribed burning is essential in our forests to allow firefighters the opportunity to suppress fire before it becomes too large, and to provide a balance of age classes after fire for the maintenance of biodiversity. It is also critical to enhance the safety of our firefighters. There's a downside, of course. The weather conditions that are most favourable for precision burning are stable and result of smoke moving into and through urban areas. Smoke is a severe irritant to some people and may precipitate asthma or other allergic reactions. But in the divine scheme of things, smoke was not put there just to irritate the human race. Smoke stimulates flowering of many native plant species and has a role in breaking the dormancy of the seed of many others. Smoke is that part of the ecological process we call fire and a natural part of the ecosystem we call Earth. Unfortunately for bushfire managers, during the late 1970s, smoke became unpopular. It started with the discouragement and later banning of backyard incinerators and the burning of autumn leaves and other garden debris. Wood fires became the next target, and residents were encouraged to fight air pollution by converting to gas and oil. In the onset of the late 1970s, of environmentalism and its concern for conservation of native species, we saw the great decline in prescribed burning for fuel reduction in the ACT and nearby New South Wales. Environmentalists vilified the burning of native bushland, but they had no understanding of the essential role that fire plays in the regeneration of native species and creating a healthy habitat for both flora and native fauna. Moreover, Canberra's demographic profile was changing dramatically. Increasingly, the population was city-bred or immigrate from another country where intense fires just did not happen. These people had absolutely no comprehension of the destructive power of the Australian bushfires. Large fires had occurred in and around the ACT between 1960 and 1990, but these were out in the country or skirted around the Canberra suburbs. For example, on the 6th of March in 1965, a day of extreme fire danger, two large fires within 100 kilometres of the ACT, and each burnt around 100,000 hectares. Canberra was in between and also experienced fire weather, but we were lucky. No fire started in Canberra. In 1985, fire started on the eastern side of the city and burnt away slowly into the prevailing westerly wind and threatened the backyard fences. But these fires gave the residents little indication of the speed and intensity of the headfire that trapped and killed firefighters at Burra. As often happens in Australia, a period of high fire activity was followed by many mild years. There were no serious fires in the ACT for another 18 years, and during this time, bushfire agencies became better equipped and more efficient at suppressing small fires. The community became complacent. Fire disasters were something that happened somewhere else. It seemed unnecessary for individual homeowners to take any action whatsoever to protect themselves. The attitude of the media also changed. It changed dramatically. Fires became theatre. With access to the helicopter and the telephoto lens, even a wildfire can be turned into a dramatic spectacle. In this scenario, there was no interest in the root cause of the problem. The spotlight turned to suppression and the heroics of the volunteers, and few people reading the newspaper or watching the television news realised that firefighting, particularly in a forest, is a hard, tough and dirty job, and is only successful when flames are less than a metre high. But, moreover, when firefighters put out fires when they are small, there is no news, no congratulations, and no medals. In January 2003, this is the year of our fires, lightning ignited 5 fires in the forests of the Brindabella Range. These fires could not be suppressed, even though there were 10 days of mild weather. Fuel loads in the forests, burnt 25 years ago, now had more than 25 tonnes per hectare. Fuel reduction will stop fires in the first 18 to 24 months after burning, but it will reduce the speed, intensity and combustion time of a fire for another 10 to 8 years, making suppression easier and safer. After the mild weather on the 18th of January, extreme weather occurred, and the fires joined together and burnt into the western suburbs 25 kilometres east of their ignition points. The fires impacted some 14 kilometres of suburban perimeter. If only one of these ignitions had been suppressed, this distance of impact may have been halved. 2 separate head fires burnt into the suburbs, one from a pine plantation at Duffy at 1500 hours, and another an hour later and 2 kilometres south at the suburb of Chapman. The second head fire burnt through a sparse, grassy woodland with a wide, mown firebreak of grassland. We were surprised that the pattern of house destruction in the suburb was clumped rather than random. A random distribution could be expected if there was ignition from firebrands. But more importantly, the pattern of destruction in the suburbs was the same, whether the fire emerged from the pine plantation or the grassland. In both suburbs, the most severe and continuous damage had occurred where residents had planted up native gardens that linked together and at times included public parkland. We measured the fuel loads in the unburned suburbs outside the fire area, and this suggested that the fuel, where there had been native gardens, was around 25 tonnes per hectare. That's 10 times the weight of fuel in the grassland and 5 times higher than the fuels in the pine plantation adjacent to Duffy. And although the flames emerging from the pine plantation were spectacular, they were 2 to 3 times the height of the canopy, they did not influence the ignition pattern downwind. It was determined after the collapse of the convection of the head fire and was propelled when strong gusts of wind blew cascades of bark from the beds of wood chip mulch, and they blew it into the houses over 100 metres downwind. In other parts of the world, it is also true that it is the urban fuel that spreads fire in the city. Now, the Oakland Berkeley Hills fire in California on October 20, 1991, started and burnt entirely within the established suburban area. Homes were intermixed with closely spaced eucalypts and Monterey pines, better known to us as radiata pine. We grow that in our plantations. And these fuels overtopped many of the houses, together with an understory of flammable Californian shrubs. The fire weather was slightly less severe than experienced in Canberra on 18 January. Hot, dry winds averaged 35 kilometres an hour with gusts to 80 kilometres an hour. Although the fire burnt only 650 hectares, it destroyed 2,500 single-family dwellings and 437 apartment buildings and killed 27 people. It built up so rapidly after ignition that 790 homes started burning in the first hour. A few months later, in January 1992, a similar situation occurred in the Sydney suburbs of Como and Janelli. These suburbs also were deeply inside the built-up area of southern Sydney. They were thought to be protected on the western side by the Warrenara River. But firebrands travelled more than a kilometre across the river and started 3 spot fires into a mere 30 hectares of bushland reserve between the river and the houses. The bushland was long unburnt and carrying very heavy fuels, and the fires could not be controlled until they had burned around 200 homes. Now for you Yanks, here's a story of the Maui Fire, Hawaii, 7th August 2023, which burnt only 880 hectares, mostly in the built-up area of Lahaina, but killed 98 people and destroyed 1,800 houses and 300 commercial and other buildings. The fire started in an abandoned sugarcane plantation close to the city and burnt through a mixture of introduced grasses and sugarcane and buffel grass. Was driven by cyclonic winds with gusts up to 130 hours, but there was no warning and quite a wide impact perimeter. Within the built-up area, the fuel was garden vegetation and closely packed wooden houses. Residents had been used to regular burning of sugarcane in the past. This burning ceased around year 2000, and now they were caught completely unprepared and unfamiliar with fire. This year, in February 2024, in the Valparaiso region of Chile, wildfires burning in extreme weather have destroyed more than 6,000 houses and killed more than 130 people. Around 70% of the region's destroyed homes were concentrated in irregular settlements called Toma Ilegales. These settlements were so combustible with trash-strewn streets, no building regulations, so houses built with cheap, flammable materials and crowded together with narrow streets. However, a new suburb of Villa Botanica, there was a community project where residents controlled the vegetation and cleared trash, and there were no losses. In Australia, our houses in the southern areas are mostly brick and well spaced, but residents still have to take their part. They have to reduce flammable dead fuels in their gardens and make wise choices of trees and shrubs that do not collect abundant dead material beneath their crown. People who want to have native gardens should be encouraged to safely burn excessive fuel, let's say in incinerators or fire pits, even if only to expose them to the nature of fire and appreciate what constitutes the fuel for a bushfire. Now, if the city beautiful of our dreams is to have the character of the Australian bush, we have to accept that fire is part and parcel of that character. We have to manage fire, and the only thing we can manage is the fuel. We have to accept that prescribed fire used to reduce fuel loads all produces smoke, a natural response that is part of the bushland ecosystem. People who are sensitive to smoke need to take individual actions to protect themselves, just as people sensitive to skin cancer need to take individual protection to protect themselves from the damaging rays of the sun. If we do not accept this proposition, the alternatives are bleak. If we don't revert to the original plan of a city of exotic trees and irrigated lawns, we must create an environment of tar and cement, or face the prospect of increasingly bushfire disasters in the future. Thank you, Mike. That's it.
Phil, that was great. Thank you for sharing your paper with us. That paper is relevant to a lot of areas in the world, like you talked about, and we all really appreciate it. Again, thank you. We're doing this for all of you. If you like what we're doing, please give us a thumbs up, hit the subscribe button, and leave a comment below. See you next time.